All right, this is differential equations. We're doing activity 621 part D. So here we have the same left-hand side as part C, but we've got trouble. We've got an e to the 2t cosine 4t, which we saw show up last time. So now we, I guess we'll take inverse, we'll take Laplace transform. Do you want to get down? Yeah? Okay. You want to say goodbye to my students? Say bye.
Bye.
Say good luck on your final.
Final.
Okay. All right. Now we are doing s squared x minus 2s minus 0 minus 4 times sx minus 2 plus 20 equals, and then the Laplace transform here is Laplace transform here to do the e to the 2t cosine 4t, e to the 2t cosine 4t, that's s minus a, so s minus 2, and there's a 2, can't forget that 2, 2 times s minus 2, over s minus 2 squared plus 16. Okay, and so now, here we go. So then we've got s squared minus 4s plus 20 times x, and then minus 2s plus 8. Oh, there's a big x there. Equals that. So then s squared minus 4s plus 20 times x equals 2 times s minus 2 over 2 s minus 2 squared plus 16 plus 2s minus 8, and then find a common denominator. You know what? We'll just wait a second. There's no 2 there. Can you talk like a 3-year-old instead of like a baby? What are you saying?
I put the truck in the bathroom.
Interesting. All right. So here, I'm just gonna, let's just divide. Let's forget about finding a common denominator. X equals 2 times s minus 2 over s minus 2 squared plus 16. And then that's the same thing there. So squared, because we know, if you recall from last time, splitting the square, plus 2s minus 8 over s minus 2 squared plus 16. All right, now, this problem is a disaster because it's a partial fractions disaster, because you have this term squared. So if you have that term squared, remember it from partial fractions from Calc 2, that means we would have to have like an as plus b over like a s minus 2 squared plus 16 squared plus a cs plus d over s minus 2 squared plus 16. And so that's all you can do with partial fractions, and you still have this. And this is nowhere in your Laplace transform table from the last section. The only way to deal with this is to go ahead to a section we're not going to cover in this class, 6.4 on convolutions, and then do some fancy trig stuff. So it's possible to solve it, but we're not going to figure out how to solve it in this class. So instead, I'm going to show you with Sage how to solve this problem. So here we have x equals that. So then we pull up our Sage.
Great
And
idea.
let's see. Let's go down to where I solved it. So first, what you got to do is define some variable names, s and t, and then define x. So in this case, x is what I had. So 2 times s minus 2. Hey guys, mommy said not to play with that anymore. Okay,
Why?
go ask mommy why.
Okay, there's this.
Eliza, put it down.
You can't play with the wrapping paper.
I need a plastic parent.
Oh, see?
All right, we're back at it. So x is 2 times s minus 2 divided by s minus 2 squared plus 16, and then that quantity squared, and then plus 2 times s minus 8 divided by s minus 2 squared plus 16. Okay, so then show x, oh dear, you got to run the code, of course. So once you make it a variable, it's okay. And then show x dot inverse of plus. So this part means I'm using the variable s, give me the answer in variable t. So then we run that. Sage thinks for a little bit, and they come up with 1/4 t e to the 2t sine of 4t plus 2 cosine 4t minus sine of 4t. And then this whole thing is times e to the 2t as well. And then we're done. So that's how to do that problem with Sage. And really, you could have used Sage even a little bit earlier. But we're trying to get you to, become not as rusty with your algebra and see how things work. So that's how we solve this problem. Now we're done.